Uh, on this slide, we've got several things combined. Here's solar activity plot. Here's 1750 to 2000. And here's northern hemisphere temperatures. Here's Arctic temperatures. Here's global average temperature. Here's U.S. temperature rising at 5 degrees C per century. And here's the sea level minus 20 years because that lags behind temperature increase. Okay, so minus 20. And there's glacier shortening minus 20 years, same thing. Well, if you look down, can you see down at the bottom here? Slight growth in primarily the use of coal, and then we started using some oil, and there was a period in here where there's basically no increase. Then we went through a threefold increase, and then we went through a twofold increase. Well, what happened here? We go up, we go up. While things were standing still down here, we had an increase in temperatures that show up a little bit and they correlate with an increase in solar activity. And then, gee, when this starts to increase at a threefold rate, guess what? We have a little drop in temperature there, as indicated by all of these different measurements that have been made. Some of them are based on satellite data. The more recent ones, there's a lot of balloon data that went into this as well. And of course, some of them are surface temperatures as well. Now, there are problems with surface temperatures. You got to be really careful. Where do you measure temperatures at the surface of the Earth? We have the next slide. Okay, this is a summary of global northern hemisphere, southern hemisphere tropics. This indicates that the balloon data and the satellite observations match very well. Okay, next. Oh, excuse me. There's one back. You see this bump? El Nino, 1997-98. There are other factors that influence the business of glaciation, interglacial periods, that influence the magnitude of the temperature changes that take place. There's ocean circulation problems, El Nino. There are also problems about other contributions to the atmosphere like dust or volcanic ash. So there are a lot of other things to look at when you're looking at what the total picture is about the fluctuation of temperature back through time. I'm trying to hit what I think are the big high points and as it relates to the issue of hydrocarbon use. Okay, next. There's another big factor about the surface temperature measurements. What this represents is taking a look at the surface temperature trends 1940 to 1996 in the something like 57 counties of California. And that's plotted against population density. 10,000, 100,000, 1 million, 10 million. Okay? Gee. The temperature in California was rather low if you take measurements where you are having low population density. This is the heat island effect of large populations. And I'm sorry, but a lot of the modeling that was done, I don't know whether it's still being done, I just don't know. But a lot of the modeling was done, didn't take this factor into serious account at all. And there's a big difference about what surface temperatures look like depending on where you take them. Next slide. This is going to be the last slide. This is a slide that says, gee, what would the impact be in terms of heating up the Earth over here in watts per square meter if you doubled CO2, if you doubled it, okay? Well, here would be the effect. What are these over here? These are the uncertainties in several of the models that are being used. The uncertainty on this scale for ocean surface flux, for north-south heat flux, by motions, by humidity, by clouds, etc. This is just taking and doubling CO2 and say, what would the impact be? As compared to what some of the uncertainties are in some of the models that are being promulgated to try to explain global warming. We have climate change. We've always had climate change. We'll always have climate change. We have been going through an interglacial period, coming out of a glacial period, going to the peak of an interglacial period. This is the hottest time the Earth will be in these cycles of glacial and interglacial periods. We need to have more observational data. We need to have a more detailed look at what the geologic record shows us about past climate change. And these data need to be included in the analysis and the discussion of what we should be doing in society because of climate change or global warming. We ought not rush. We've got a few days or weeks or years to make these decisions. We ought not rush to judgment and make societal decisions based on either faulty, incomplete, inadequate, or just plain wrong science. And there's a lot to be learned from the geologic and a very high density observational record in more recent time. Thank you. One question?
Yes.
Sorry.
Be quick.
Yeah. Is the natural disaster has any impact on the climate change? I know
You mean
about
like
volcanic-
earthquakes and?
Volcanic activity has some impact on
Oh, yes.
earthquake and
Earthquakes?
tsunami and storm surge. And
I don't know about tsunamis, but I certainly know about volcanoes.
volcanic, I know.
one
But
vol-
the other disaster.
Yeah, I don't, there are some things, natural things that take place, like El Nino, like La Nina, like volcanoes, like periods of very dry climate where we have a lot of wind producing a lot of dust in the atmosphere. There's a lot of dust in these ice core data. And this helps to explain the magnitude of the temperature changes, okay? Because just the Milankovitch cycles aren't enough to give the magnitude of this 4 to 10 degree range. They can account for 2 to 4 degrees of it, but they can't account for it all.